What is up, guys, and welcome to episode 2 of Hack the Coding Interview, hosted by Region 3 NSBE. Today's company of focus is Oracle. Just as a refresher, my name is Esther Onema, and I am a junior at the University of Central Florida, majoring in computer science, and I also happen to be your Region 3 telecommunications chair. Once again, these are some of my past internship experiences working as a software engineer. I just want to spread my knowledge as to some of the questions that I encountered in these interviews and other interviews. So, yeah. What this series is not. Okay, this series is not a guaranteed set of questions that will be certainly asked during your interviews. These are just past questions that have come up in previous interviews. And I believe these questions should serve as a solid foundation for your interview prep. This isn't a one and done tutorial either. Challenge yourself by going beyond these problems in order to become better prepared for your interviews. Also, supplemental problems will be provided at the end of each video. And then another thing this video isn't, it's not sponsored. This is being brought to you guys 100% free of charge on behalf of the National Society of Black Engineers, Region 3. What this series is for: coding in real time, and we're coding approaches to essential interview questions. We're reviewing basic programming concepts for not just beginner programmers, but also experienced ones. And this is also a way of you guys having like a virtual paired programming session, so you're not programming alone, and relieving first-time interview jitters. Materials needed for today's video: same thing as last time, the IDE of your choice, the programming language of your choice. I make sure to write my code in a way that's like easy to be transposed into other languages. And also, you're going to need another device aside from the one that you're currently using to watch this video on, so that you can program on one device and watch this video on another, so you're free of distraction. Last thing you're going to need is an optimistic mindset, of course. Anytime you're feeling groggy or like you're not able to focus anymore, drink some water, put yourself in a productive environment, and if things get really, really tough, pause the video, and when you feel like coming back to it, come back to it. One more thing, last thing, always remember that in an in-person interview, you're always going to want to communicate your thought process out loud. Essentially what this does is it lets your recruiters know what exactly you're thinking, and it also explains to your interviewer what you're coding without them having to stop you. If you can't understand the question being asked by your recruiter, request a test case. Example, you can ask the interviewer, okay, what are my input parameters? Is it a string? Is it an array? What am I returning? Am I returning a list? Am I returning a set? And also restrictions regarding the code itself. Sometimes your interviewer may ask you, okay, don't create an array when you solve this problem, or don't use a hash set when you solve this problem. All very important things to bring up in an interview. And if you can't think of the optimal solution, brute force it. One answer is better than no answer. And last thing is, make a great impression. Make sure you do your research. Ask questions at the end of your interview. This kind of shows your interviewer that you're engaged and actually interested in working in the company. So, yeah, let's get started. Once again, supplemental problems will be provided at the end of the video. All right, so let's get started with our first question. So this problem is going to be Roman to integer. So at this point, I'm pretty sure we're all familiar with Roman numerals. Essentially, the question is, given a string of Roman numerals, convert it to its integer representation. And here, of course, we have our key where I is 1, V is 5, so on and so on. And essentially, once again, all this problem is asking us to do is, given a string representation of Roman numerals, convert it to its appropriate integer value. For those that are interested in reading the problem in its entirety, I highly suggest you go ahead and pause this right here, but I feel as if the question itself is pretty self-explanatory, so we can just jump right into the coding. And one more thing before we go on into coding, I use this website titled leetcode.com, and it's a really awesome website in general where you could look up problems by company, difficulty, and also how often it's asked in interviews. So for those who want additional practice, I pull my questions from here, so I highly suggest LeetCode. So let's start coding. Okay. So I've already created the skeleton for the code itself. Like always, we always start by commenting our code. The first point being create a map to have easy access to character values. And we're going to be using a hash map today simply because it has O of 1 insertion as well as O of 1 lookup, which is a pretty optimal runtime for this sort of operation that we'll be performing. So let's make our map. Character integer, meaning we're going to input a character, and for every unique character, it's going to return an integer. We'll call it our dictionary. Did I spell that right? Equals new hash map. Yep. And right now, we're just going to be putting all of the values outlined in our key into the hash map itself. So for example, we're going to say dictionary dot put, and then we said the first value was I, and that equates to the number 1. And then we're just going to continue this process for the other Roman numeral characters that were defined in our problem statement. I think that's all. So next we have this, which equates to 5. X, which equates to 10. L, which equates to 50. C, which equates to 100. D, which equates to 500. I didn't even know this before doing this problem. So you learn something new every day. And then M, which equates to 1000. Okay, so we have our hash map all figured out once again. Our hash map contains unique characters, and every character is mapped to an integer, which is its integer representation. Okay. Make sure I don't have any spaces. Yep. So let's create an answer variable, which is, of course, the variable we're going to return at the end of our function, an integer. And now we want to create a for loop that goes through all of the string, through the entirety of the string, except for the last character in the string itself. That will be explained, but for int I is equivalent to 0, I is less than s.length, which is the length of our string, minus 1, and I plus plus. And once again, we don't want to go through the entirety of the string. We want to go through the entire string except for the last value. And then now we want to collect the current character and the next character. So essentially, we're going to be analyzing 2 characters at a time for our given string. So we would say char current equals s dot char at I, and char next is equivalent to s dot char at I plus 1, right? Awesome, awesome. Now, condition. If the current character we're looking at is greater than or equal to the next character, we're going to add the current character's value. So what is this saying? So the current character we have in this case is I, because we're at 0. The next character, of course, also is I, because the next index points to the value 1. So we're saying if the current character, I, is greater than or equal to, which it is, the next character, we're just going to add its integer representation to our final answer. So by doing that, we're saying if dictionary.get current is greater than or equal to dictionary.get next, our answer plus equals dictionary.get current. Where by calling .get, remember current is currently at the string I, and in our hash map, the value of I maps to the integer value of 1. So our answer plus equals 1. Otherwise, else, subtract the current character value from the final answer. So rather than adding its value, its integer representation to the answer, we're actually going to subtract it, and I will explain why. So it's going to be answer minus equals my map, well, dictionary dot get current. Okay, so why are we doing this? Let's say rather than the next character being 1, it's actually 5. So in this case, we're going to enter this else condition. Now we're saying the next time we go through the loop and we're at the value of 5, right? We're not going to plus equal 5. Actually, yes, we would be plus equaling 5, but it's important to note that we subtract 1 from the entire answer because IV together equates to 4. So yeah. Let's say, once again, we've recognized that 1 is less than 5, so rather than adding our sum, the value 1, we subtract the value 1, so then our answer would be -1. So then when we come around next time and we're analyzing the value 5, right, because v equates to 5, we're going to be plus equaling 5. So -1 plus 5 is 4, which in total is IV. So now, once we are out of the for loop, examine the last character and add it to the final answer accordingly. So then we can just say char last equals s dot char at s dot length -1, right? And then we're going to say answer plus equals, plus equals, dictionary dot get last. And why do we always save the last character in our string outside of the for loop to evaluate? Simply because in this case, we have no next character to compare it to if we're looking at these two lines here. So when we're at the last character in our string, we're always going to evaluate it by itself. And then, of course, we're going to return the answer. So return answer. All right, and let's see if this works. Of course, cannot find symbol. Interesting. S.chart at. Oh, spelling error. All right, and let's run the code. Once again, we fed it the string 111, which should be 3, but let's see if that works. Yep, the integer representation of the given string is 3. Now let's try inputting some other test cases. So let's say ix should be 9. Let's try that on Go. Yep. Perfect, perfect. Ooh. Let's cross our fingers and hope this one works. $19.94. And yep, the output is 1994. So if we were to look at this code as a whole, at the end we can analyze the runtime as being pretty self-explanatory. It's O of n, where n is the length of the string s, right? And then our space complexity is O of 1, simply because it is, our space complexity is O of 1 because we created a hash map that is always going to be of the same size. So that constant number in this case is 1, 2, 1, 2, 3, 4, 5, 6, 7. And we wouldn't say O of 7. 7 is a constant number, so we just say O of 1. And there we have it, Roman to integer. Symmetric tree. So given a binary tree, check whether it is a mirror of itself, i.e. is it symmetric around its center. So let's say we have this example here where our tree looks like this. It is considered symmetric because every node's mirror node is the exact same value of it. So left, right, they're both equivalent to 2, right? So the left node of the left subtree, its mirror, is the right node of the right subtree, and they're both equivalent to 3. So yes, that is valid. And the right node of the left subtree's mirror is the left node of the right subtree. And since they are also both equivalent, this also further proves that this binary tree is symmetric, because every tree node's mirror node has the same value as it. But of course, the following is not. As we see here, yes, these two tree nodes are equivalent, but this is null, right? Because remember we set up here the mirror image of the left node in the left subtree is the right node in the right subtree, and null and 3 are not equivalent, therefore this isn't valid. And then we could say the same for this node here. Its mirror image would be here, but unfortunately it's not, it's null, so it's invalid. So let's go ahead and code it. Just as a heads up though, we're not going to actually be inserting values for our tree to save time. I really want to get across the overall concept as to what we're trying to do when we code this solution. So let's get started. This symmetric is going to return a Boolean true or false, and it's going to take in two nodes, the left node and the right node, both tree nodes, where we have defined the tree node as a struct here, where it has a value, and then it has a pointer to that node's left and right children. So let's get to coding. So we're going to say if both of the analyzed nodes are empty, they are symmetric. So if they are both null, they're both equal. So let's say if left is equivalent to null and right is equivalent to null, we're going to return true. Now, some of you may be thinking, I have no idea what you just said. That is okay. I have also made a graphical representation as to what this case looks like. This case looks like case number 1 right here. The left tree node and the right tree node are both null. So technically, it is symmetric. Well, it is symmetric because the left node has a similar value as its mirror node. All right, so the next case. If one, but not both, of the tree nodes are null, return false because they're clearly not symmetric. So in that case, we could say if left equals null, right? Or right equals null. Notice we didn't say and because they're both not null. And if they were both null, this would have fired off as true. We wouldn't have gotten this far. So we're going to return false. What does this situation here look like? Case 2. Let's say left tree node is null and right tree node is 2. Obviously not symmetric because they don't have identical values. Or the other case could be maybe the left tree node actually has a value and the right tree node is null. Once again, this isn't symmetric because they would have the same value at each tree node, left and right. Okay, so if both nodes have values, but they are not equivalent in value, we're going to return false. So if left.val doesn't equal to, does not equal to right.val, return false. What does this situation look like? We're going to go over to case 3, and it's going to look exactly like something like this, where let's say we have 2 here on the left node and 3 on the right node. Obviously, these two values aren't equivalent, so it's going to return false. You know, in order for it to be symmetric, both of the tree node values have to be equivalent. Awesome, awesome. Last thing, let's recursively call the function to analyze the remainder of the needed nodes when identifying symmetry within our tree itself. So we're going to say, like every recursive call, return is symmetric, where we're going to pass in left.left and right.right. So what is happening here? So remember how we said we're always going to pass in the mirror image of each of its tree node? Like that's how we're going to do the remainder of our comparisons, right? So what I'm saying in here is we're going to pass in the left trees, left tree nodes, left child, and the right tree nodes, right child, which would be this, left tree nodes, left child, and right tree nodes, right child. Why? Because remember, we said the mirror image of the left tree, left child, is the right tree node, right child, which is why these two will be passed in together, because we will be comparing these two against each other. So then, as you can assume then, we also need to check the symmetry of the other two positions, as we had discussed. So then we would say the left tree node's right child will be also compared to the right tree node's left child. And that will be defined here. And is symmetric. The left tree node's right child and the right tree node's left child. Good stuff, good stuff. And yeah, that's it. That's just the question written over again for reference, but that is pretty much it. Last thing we need to talk about is runtime. Runtime, pretty straightforward. The space complexity is going to be the hard part. But runtime is O of n, where n is equivalent to the number of nodes in our tree. And our space complexity is actually O of n. Now, some of you may be thinking, what? We didn't even create an array or a hash map or a hash set. It should be O of 1. False. Because we're using recursion, for those that have studied recursion or even glanced at it, the way a computer processes recursion is by putting every call of the recursive statement into a stack. Now, that stack is relative to the height of our tree that we're analyzing. The worst case scenario, the height of our tree could be a straight line, meaning it could be O of n. Therefore, our space complexity is O of n because it is relative to the tree height, where in the worst case scenario, it could be a straight, I'm not sure if I spelled that right, straight line of length n, O of n. And there we have it. So given a binary tree, return the level order traversal of its nodes values, i.e. from left to right, level by level. Hint, hint, hint. Level by level is kind of pointing us to use a breadth first search algorithm. For those of you that don't know what it is, I highly, highly recommend you look into it. It makes traversing your tree super, super easy. And it also looks good to your interviewer, of course, that you know what a breadth first search algorithm is. So here's an example. We have our tree, and the level order traversal is going to be 3 as the first level, and then 9 and 20 as the second level, and 15 and 7 as the third level. And this is the outline of the function itself, where you take in a tree node root and turn a list of integers. Not much to it. Next, problem number 2. Another tree. So given a binary tree, return the zigzag level order traversal of its nodes values, i.e. from left to right, then right to left for the next level and alternate between. Once again, we have this tree. So we're going to go from 3, 20, 9, 15, and 7 in a zigzag shape essentially. And once again, we're returning a list of integers, taking in a tree node root as our input parameter. And once again, another huge hint, use a breadth first search algorithm. Yeah, it's pretty important. Thank you guys for watching today's video. Do some practice. I hope to have the GitHub posted this weekend, so you'll be able to see the solutions in our Region 3 GitHub page.